Okay, in this video, I'm going to do some quotient rule problems. So if we have a function that is the quotient, right, the division of two different functions, we'll call this one f and g. So g is in the f is in the numerator, and g is in the denominator. Then our derivative is the low function times the derivative of the high function minus the numerator times the derivative of the denominator function divided by the denominator of the function squared. So low d high minus high d low over low low is sometimes how you hear this thing pronounced. So we're going to do a couple of examples with this. There's some algebraic ones, and there's some trig ones, and that one even has a nice radical in it. So let's jump right in with the quotient rule. Low d high minus high d low over low low. Get my pen out. Here we go. So if we're going to apply this quotient rule, that is the low function of the denominator, 3x plus 7, times the derivative of the numerator. So 2x minus 5 has a derivative of just 2. So 2x minus 5 minus, once again, that 2x minus 5 is now its true function, 2x minus 5, times the derivative of the denominator, which in this case is just 3, all divided by my denominator, 3x plus 7 squared. Okay, so low d high minus high d low over low low. So now I need to do some simplifying, so I will distribute 6x plus 14, and I will distribute into this minus 6x minus 15, all divided by 3x plus 7 squared. Okay, now it might be okay to not square that out just yet to see what happens, but we will take care of this minus on top. So minus 6x and plus 15 when we distribute our negative, all divided by 3x plus 7 squared. So it looks like when I combine my like terms, the 6's cancel out, and I get a derivative of 29 over 3x plus 7 squared. Okay, so it would not be beneficial if I were to square out that denominator, so I'm just going to leave it like this and be perfectly happy as the derivative of that initial quotient. Okay, so let's see. Here we have a nice trig one, but we're still going to apply that same rule. Here is your denominator, and here is your numerator. So we'll start off with the low function, or your denominator function. That would be 1 plus sine x times the derivative of 1 plus cosine. So there's no derivative from 1, so the derivative of cosine is the sine. Okay, and then minus, low d high minus. Okay, and now we have the 1 plus cosine numerator function times the derivative of the denominator. So there's no derivative from 1, so derivative of sine is cosine. Well, let me go back here, sorry. The derivative of cosine is negative sine, so let me slap in a negative here. Negative sine, sorry. Forget about my negatives sometimes. I apologize. So derivative of cosine is negative sine. Now divide all this by 1 plus sine squared. Okay, so let's do our distributing. Negative sine times 1 is negative sine. Negative sine times a plus is a negative sine squared. Okay, and then minus, we're going to do the same thing over here. Distribute our cosine into both of these. That's a cosine x plus cosine squared. X all divided by 1 plus sine x squared. Okay, so I'm not going to multiply that out yet, not until I see if I can, if it's beneficial. So now I'm going to subtract, right, distribute my negative into here. So I have negative sine minus sine squared minus cosine squared. So I am seeing something that might remind me of a trig identity. Okay, namely that sine squared plus cosine squared equals 1. So if I could maybe get something like that in my numerator, maybe maybe we could do some replacing. So I'm just going to rearrange the furniture real quick here. Minus sine x minus cosine x minus sine squared x minus cosine squared x. Now see, that looks an awful lot like my trig identity, only they're both being subtracted. So what if I do a little algebra schnazzer right here, and I factor out that negative. So I'm going to pull a -1 out of sine squared and cosine squared. So now it's sine squared plus cosine squared. That looks better. When they're both a negative, I can factor a negative out from both of them. Okay, so now I'm going to replace all of this with just the number 1. Okay, so I can replace sine squared plus cosine squared with 1. So minus sine x minus cosine x minus 1 all over 1 plus sine x squared. Okay, so once again, we could do one more thing with this, maybe make the whole entire thing negative because each of these terms, so the negative can come in the front, and maybe I'll make this sine x plus cosine x plus 1 all divided by 1 plus sine x squared. Okay, so it does not improve my function at all to multiply out the denominator. So let's just go ahead and leave it underneath there, just like that. Okay, so sometimes it's handy to remember our pre-cal, our trig identities. They can help us do some simplifying. Okay, back to another algebra one. So we have root x on the denominator and 3x plus 7 in the numerator. So we start with the derivative, or the low, times the derivative of the high function, which is just 3 in this case, minus our 3x plus 7 times the derivative of root x. Okay, so remember, root x is x to the 1/2 power. So when we use the power rule, the 1/2 comes to the front, and then we have a negative 1/2 as its power. So if we simplify this, we get 1 over 2 root x. Okay, so that's what I'm going to multiply by 1 over 2 root x, which is the derivative of root x over root x quantity squared. Okay, so let's see what kind of algebra we can simplify here. We have 3 root x minus, let's do some distributing here and see what I get. 3x over 2 root x minus 7 over 2 root x. Okay, so it's a minus, so I'm subtracting both of these terms and distributing all at the same time. Hopefully you're okay with that. So minus 3x over 2 root x, and then minus 7 over 2 root x also. And in our denominator, root x squared is just x. Well, that's pretty handy. Okay, let's see what I can do here. I notice I have a denominator of 2 root x and another denominator of 2 root x. And this one here doesn't have a denominator, well, it has a denominator of 1. But if I want to combine all of these things in my numerator to simplify, I'm going to have to multiply this by my 2 root x over 2 root x. So that now this guy will also have a denominator of 2 root x. And in the numerator, 2 times 3 is 6, and root x times root x is x. Okay, so now I have something that might look more complicated to begin with, but it's actually going to help us out a little bit, because now I can combine all of these fractions on top. So it's 6x minus 3x, that's a 3x, and then minus 7 all over 2 root x divided by x. So now my last step, rather than dividing by a fraction, I'm going to multiply by the reciprocal. So 3x minus 7 over 2 root x times 1 over x. Okay, and there's not a whole lot we can do here, but we can multiply on the outside of our denominator. So 2x root x would be the derivative of that thing that I started with. Okay, yes, lots of algebra involved, lots of these fractional rules and exponent rules, and trying to add and subtract with common denominators and all of that wonderful stuff that you've been taught your whole life. Okay, last one, we have a trig one, right? Y equals cotan. So I'm going to start off by rewriting cotan as a fraction. Cotangent is the cosine of the angle divided by the sine of the angle. So now I have it as a quotient, and I can take the derivative. So the denominator term, low, times the derivative of cosine, which is sine, minus the cosine times the derivative of sine. Did I do it again? I did it again. The derivative of cosine, sorry, is minus sine. So this is a minus sign here. Derivative of cosine. All divided by sine squared. Okay, the derivative of cosine is negative sine. I need to remember that always. So we have negative sine squared minus cosine squared, all divided by sine squared. Okay, now this looks a lot like what we had a second ago. Both of these terms are negative, so we can pull the negative out of them both, leaving us with this wonderful Pythagorean identity, all divided by sine squared. So just like in the previous problem, I'm going to replace sine squared plus cosine squared, all of this with 1. Because that is our Pythagorean identity from trigonometry. Negative 1 over sine squared. Okay, this is also a trig identity. 1 over the sine is known as the cosecant. So if I have 1 over the sine squared, that must be the cosecant squared. And the negative is out here, so the negative stays there also. So the derivative of cotan is negative cosecant squared, if I did my math right. I believe I did this time. Okay, so there's a little bit of practice with our quotient rule. If you have a fraction, the quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared.